You know, there's little mud skippers you see, you know, like little...
All those nasty things. They're just slimy.
Harsh. Poor mud skippers, if you're listening.
Hi, and welcome to Wonder, the Planet Earth podcast for curious people. I'm Holly Cook, joined as always by fellow Earth scientist Dr. Anthony Reid. We have probably dropped 5 or so episodes with some pretty spectacular scientists. Oh, maybe 4. Maybe my maths is off today. But anyway, point is we've had some pretty incredible conversations with a range of tectonics people and landscape people, not dirt people, soil science people. Anthony, I think it's time that we take a pause for a second, and I would really benefit from just talking some of this out with you.
Definitely.
What do you think? Because my brain can overload.
Oh, easily. Yeah, it's worthwhile to reflect on what we've kind of been discussing, and maybe can solidify some of the learnings and sit back and enjoy it. You know, it's just so nice to listen to these really deep experts in their domain, and when they're in their kind of deep in their knowledge and just teasing some of that. It's such an exciting thing to be doing. So thanks.
Yeah. Even little details, right? Thematically, I can remember what we went through, but there are some jewels in there in terms of little concepts we speak through. One of those jewels that really has framed the way that I've been thinking the last couple of weeks. Truthfully, this podcast seeps into my life. So it's framed the way I've been thinking is firstly, stillness. I think I recalled when we spoke with Dr. Andrew Meredith, University of Adelaide, what I led with was I woke up with the morning kookaburras and I felt stillness, and I was latching onto that stillness because I needed to ground myself, truthfully. And I brought to Andrew's attention, Andrew, this stillness, is this a real concept? Is this just something that I'm making up? Is nature still? And Andrew said, not really, but that's okay that you feel that because it's deep time that's not necessarily still. You have movement of tectonic plates, you have movement of carbon, you have movement of magma. Everything around us on this earth is a planetary amalgamation that is the result of not being still.
Definitely. I thought it was interesting also the way Andrew talked about the time scales of observation. So he sort of said, when we're living our little short lives and we do, listen to the birds or whatever in the morning, it seems like, the bird song has forever been thus, I
actually really like cockatoos. I like the quack. Yeah, you think it's always been.
It's always been. And you can picture thousands and thousands of generations and, a deep time aspect to those calls. But they haven't always been thus. And as you say, when you look back in deep time, then you really see just this kind of constant series of change and sort of dynamic processes that make up.
And some of it's harder to imagine than others.
Oh, sure.
Kind of all of it's hard.
Well, that is true. It is hard. Even for geologists, it's hard to imagine. But yeah.
Yeah, absolutely. And then you try and, it is hard to imagine. One of my favourite things to think about is this with Andrew, was this disintegration of continents. What do you mean you have mountain ranges that disintegrate into dust, but that dust then goes into the oceans and it forms substances that then draw down CO2 from the atmosphere? All of this just feels so ridiculously in the clouds, literally.
Yeah, it's
carbon dioxide in the clouds.
Outrageous. It's outrageous and it's wonderful. It's the spectacular interconnection of all these processes, like you say. So he talked about the carbon cycle, and we got examined on the carbon, organic and inorganic carbon cycle, which is
on him being a teacher, and I didn't say this at the time, but some of the most important people in my early years were my teachers.
Totally.
And I don't know if there are teachers listening to this, but if there are, I think that you guys are super valuable. A lot of who I am as a scientist today comes back to my year 12 chemistry teacher, Dr. Head. He had a PhD in organic chemistry and then spent his life teaching high school students. And, there are teachers out there, they're legends. So I just wanted to
shout out to the teachers.
Literally, shout out to the teachers.
Yeah.
But you're right, the carbon cycle, I felt like I was back at science.
Back at school. Yeah, well, it's great to take it out of the classroom as well. And so when if you're driving around and you see a hill or you see a mountain or that sort of stuff, or you see a river carrying sediment or even just flowing with dissolved magnesium and calcium out to the ocean, that is a process which is the kind of living, if you like, expression of the carbon cycle, right? So Yeah, I thought it was amazing. I hadn't really thought about how important the limestones were for drawing down carbon dioxide in the atmosphere and how much change that or how that can impact over time. And so things like the kind of collision of plates, the rising of mountains, and then the erosion of mountains, and all those processes have a different impact on the long-term climate cycle that we see.
Completely. And a completely new concept that I felt like I was literally learning on the go was land plants. I know how much we've spoken about it. I know we've been going on about it a bit, but it's because it's really cool.
It's so cool.
My question, I was speaking to my partner Lachlan about these conversations, and he found it fascinating. I didn't have an answer for him, so I'm going to put you on the spot and see if you've got an answer.
Okay.
So you have complex life, right? Call it Ediacaran, Cambrian, around over 500 million years ago. And then you have plants, like little mossy algae things, sort of starting in the water. What came first out of the water, animals or plants?
Oh, great question. Well, I think it's the plants.
Yeah, because how do animals survive on land without vegetation?
What else they got to eat? But it is interesting that there's a coevolution. I think that's the point that we're trying to get to, and that animals, like the movement of animals onto land, is a whole another story as well. But part of that was changes in climate leading to drying out of of kind of lakes and rivers and things like that animal life would have been teeming within. And there's a story. There's there's little mud skippers you see. Like little
all those nasty things. They're slimy.
Harsh. Poor mud skippers, if you're listening.
Poor things actually do wonders.
This is an example, right, of adaptation to a change in environment or change in climate, and there's often a lot of biodiversity on edges, right, where there's an edge zone between one kind of ecosystem or one sort of environment, I guess, and another environment. That edge zone is often highly diverse, and this, like our nearshore environment, is the good example of that. But anyway, drying out of lakes and things like that, or rivers, which may have had little fishes and kind of creatures like that, I guess, led to things where they tried to move from pond to pond.
Oh, it's so cute,
right? And so mud skippers, with kind of used their fins, and there's a whole.
Totally.
Anyway, we should go down that road someday. But there's a whole process of evolution, right, of what led to four limbs diversifying into all the different types of animals that we see, including obviously humans and so on, but
even gravity being a problem, right? For plants,
yeah, that's right.
As if as soon as you say it, go, oh yeah, it's pretty obvious. Like I can float like a starfish in the water. Gravity does have an impact on I suppose how plants migrated out of there. So Andrew was that was an awesome.
It was great. Now, one other thing that I loved what you mentioned about this whole idea of a dance of continents, which I thought was such a beautiful way of describing that, when he was showing us his images of his models of Gondwana and that sort of stuff. So I just thought that was such an incredible thing. Another aspect of the whole kind of Gondwana conversation that we had with him was I hadn't twigged to the idea that when you have land masses in the polar regions, that's especially suitable for the growth of ice sheets because and I was just picturing think about like Siberia or this just vast desert-like place. When it snows, it just sits there. It's so cold, it turns to ice. You form an ice sheet. I just thought that was cool as well.
Completely. That's something else I spoke to Lockie about was like these processes where they occur on Earth. It's not always created equal. Like the influence and impact of these processes. Like if you we sort of touched on albedo with Andrew, saying like there are places on Earth where that effect is amplified and where it's less important. I suppose if you're amalgamating a supercontinent over the poles, you're going to nucleate ice sheets quickly.
Yeah.
Very cool.
Yeah. And that increases the albedo. It drives more ice retention because the summers are cooler, et cetera, et cetera. Just the dynamic process. Yeah.
One more question for you on this, because now we're getting into the gritty of where my own understanding gets shaky. So we have all these feedbacks, right? You have CO2 drawdown, you have mountains weathering, and in particular, Andrew reckons you have plants that are playing an effect on the climate. So how do you actually instigate the Earth's snowball into being a snowball? Like, is it the fact that these feedbacks, like just you click one or two out of place and it just spirals? I mean, I know that we can't really answer this question. I know it's complicated, but is it just that these feedbacks
Yep, it continues. It keeps getting more and more cold, and increases the albedo, and it leads to more snow, more retention of snow, more ice, etc. So there's a process of, like, say, feedback. Yep, positive feedback loops.
Yeah, exactly.
But how do you swap out of that? Because that's the interesting part as well.
We got out of it.
We got out of it, but then we kind of, we as in the Earth oscillates over tens of millions of years between a more icehouse world and a more greenhouse world, and that is part of how these supercontinent cycles also play out. And I think that whole idea of the amalgamation and then the breakup of supercontinents, that process itself generates a lot of CO2, which helps swing the Earth out of this climatic, a climatic dead end, perhaps. It's just fascinating anyway.
Yeah.
We have a great record of some Gondwanan processes in our little local geology here in Adelaide. And I know that you've been recently down to a very famous little site called Hallett Cove.
It really punches, doesn't it?
It does. There's so much there's lots of great geological sites.
Yeah.
But sometimes you get to one where there's lots of different processes all happening at once. But what was some of your reflections from Hallett Cove? I know you went down there recently.
Yeah, no, we took some first year classes down there. It's because it's like we call it our, like, natural lab, right? The record of past environments and past processes there is spectacular. You have everything from the glacial pavement, which I'll get back to, which is literally scratches in the rock from the huge ice sheet that's passed over it, scratching the rock. And then you sort of climb down in time and you end up with huge deposits of shells and fossils. And gosh, it's an archive of really spectacular, like, past processes. So we climbed up the hill to the top of this little black cliff, and you peer down on this. Well, firstly, you admire the view, right? It's a lovely view, panorama
out into the Gulf. Yeah, spectacular.
It was thundering and pouring with rain, so. But then you look down at your rock, and you can literally see a huge, like, almost gridlock of scratches, and you go, oh, maybe that's just where, I don't know, a pigeon maybe had a crash landing, and and then you look deeper and you go, no, there is a patterned sequence of grooves in this rock. And turns out that this is these are features that were, like, scratched into the rock in the Permian. So that's just after, like, 250
or so.
250 million years ago-ish, don't quote me, from this ice sheet that's passing over the rocks. Now, the rocks themselves are already older than that. The rocks are already there, right? And you have this ice sheet scratching through. And, just to out myself, as scientists are always growing, at the time I hadn't necessarily connected my conversation with Andrew about Gondwana with the Gondwanan ice sheet.
That's the beauty of learning, right?
Yeah.
Piecing things together.
Beauty of learning on mic.
Sharing your learning. Yeah. It is a spectacular little place. It's probably like half an hour down the road from the central district of Adelaide. It's easy to get to. It's a little coastal walk, and those striations, the glacial grooves, are absolutely spectacular. And to think that you're touching the surface of the landscape from 250 million years ago, that you would have been under a thick sheet of ice, probably, I don't know, kilometres, a couple of kilometres thick of ice that would have been grinding its way across the entirety of southern Australia.
Yeah.
Spectacular.
Great point.
In the middle of the great southern continent of Gondwana at the time of this, at the time of the amalgamation of so many, this big supercontinent in southern
Completely. Because I also love Ice Age. I like the movie. I love Ice Age. And so it's almost it's literally these huge ice sheets. I pictured myself as Sid. Well, it doesn't take too much imagination. But I mean, another place that I've been to recently is the Flinders. And I know for people who are listening who are even
we're getting very South Australian hypers, but
it is a spectacular place. It is very
Flinders Ranges. It's a beautiful, beautiful range of hills that runs up the spine of sort of central eastern South Australia. It's just such a lovely place.
Great, the spine. I hadn't thought about it like that. It's exactly what it is.
There's a beautiful peak near what's called Wilpena Pound that you can stand up on. And one of my really early childhood memories with my dad and my brother is camping there in the Wilpena Pound and walking up this beautiful ridge to stand on that peak, which we call St Mary's Peak, but looks out to the north, and you can literally see the ridges of the sedimentary rocks, extend just that goes off into the, it looks like the spines, like like a crocodile's or a dragon's scales that go off to the north. Just
completely. So that's I think that the peak, the traditional, the First Nations people up there, so the Adyamatna. So I think you're not really. It's asked of you to not climb the peak anymore.
Oh yeah.
And it's funny you bring this up because one of the things that I like thinking about, and my memory's terrible, so I do apologise for being vague, but the sort of aerial view of these ranges, the Hyson Range and the IBC Range, which make up this sort of Flinders Ranges, at least in that area, as a serpent. And it's like the dreaming there is that this is it's the shape of a serpent, and you go, serpent, and you go, absolutely, that's the shape of a serpent. I get it. I get it, yeah. What really struck me is South Australia, amongst algal blooms that are sort of doing odd things, horrible things to our marine wildlife in heat waves and stagnant water, amongst that sort of environmental, dare I say, crisis happening in our waters right now, we actually are really dry. I believe it's one of our driest periods on record, right? So this is a very dry state. And it's a very dry time in our very dry state. So when I went up to the Flinders, honestly, what struck me was we went up there the day after some huge rains, like the rains of the season had come in, and we're driving up there and the clouds are starting to clear. And of course, that first break of sunlight after the rains is very precious. And we were alone and we were just looking around us, and tens on tens on tens of yellow-footed rock wallabies came out in full force, and they were so cute. There were, these rocks make up little like rock ponds, and the little scraps of water that hadn't already been drained into the dry soils, those little ponds of water, they were just there drinking, and they weren't scared of us. It was almost like they're suffering and they're desperate for these waters. And I just thought, my goodness, isn't that a stark contrast to the huge gorge that I'm standing in?
Sure.
Because that the formation of that gorge that we are in came about in a time where there was lots of rain.
There must have been a lot of rain to carve these gorges.
Correct. And now I'm looking at these poor wallabies just desperate for these
tiniest little puddle that they're lapping up.
Correct.
Yeah, for
but
sure.
You told me some cool stuff about like how wet that past environment must have been.
Well, this is something that Steve Hill also talked about, with this whole idea of the changes in Australia's landscape, or the idea that the changed environment or changes in climate are etched into the landscape itself. So, we're often talking about landscape as if it's easy to picture landscape as static because that's how it appears to us going back to our early idea. But actually it's a really dynamic thing. It's a really dynamic process, and it's ongoing. It's evolving. And in the same way, like when you walk on the beach and you leave a footprint, or you walk in mud, you leave a footprint.
Yeah.
That footprint will be there until something erases it. It'll just sit there, like on the moon, for a good example. Those footprints are still there, right? So it's almost like there's an imprint of that in the Flinders Ranges, or in this example, the Flinders Range. There's a real imprint of a past climate where there was an absolute bucket load of rain. There must have been huge rains to carve these gorges down. Even they were seasonal, heavy torrential downpours, not necessarily just raining constantly, but there was some very heavy rains to carve those very deep gorges. Yeah,
exactly. And another thing I loved thinking about while up there is how fantastically those wallabies camouflage to the rocks around them. It's surely not a coincidence that it's really hard for you to see these little cute things because they're these amazing orange hues and they're grey hues. And I thought, those are the rocks. That is literally the colour of the rocks around the rock wallabies. So I'm having this like really silly realisation that of course the wallabies have adapted to suit their rocky environment, which happens to be the fantastic sediments that were laid down when first animal life was blossoming on this planet. And
Incredible.
I just thought, isn't that a travel through time?
That's brilliant. And then the other thing that Steve Hill was talking about with us in terms of like animals was his comments about the way the landscape lives in the flora and fauna, right? And so his example was over at Broken Hill that the poo from kangaroos contains a signature of the local environment. I mean, now he says that, it's like, of course that makes sense, right? Because they're eating the plants are connected to the soils. But the idea that our kind of physiology, our very, like the isotopic composition of our own bodies is an indicator of the environment that we've grown up in. Makes a lot of sense.
And even your word indicator, I would be even more dramatic than that and say that we are living extensions of each other.
Absolutely.
And especially if you go to the Flinders Ranges, there's this really well-known gorge called Bratchner Gorge, and it sort of, I won't say markets, that sounds a bit transactional, but it's famous because it's this walk through the corridor. It's like geological corridor of the evolution of complex life. And I hadn't thought about it like that before, where you go from rocks where there's no animal life, and then you hit like these weird, I don't know, they're half plant, half animal. Well, that's my interpretation anyway. They look like leaves, but apparently they were animals. But,
like filter feeding or something.
Yeah, they're
like the little spongy things,
washy, flat things that on the seafloor. I was like, oh, that doesn't really look like an animal to me, but I'll trust the scientists. And then all of a sudden, you get in your car and you cross some creeks, and then you're in rocks that have real animal life, and then you're looking at some of the first like reef building animals. And the way that it was said in one of these papers that I was reading was, it is a archive of complexity. And so what you're actually going from is a world where life isn't there to, well, simple life, prokaryotic life is there, to a bit more complex. And then you have your much more complex, you have your real reef building stuff. And then I'm there. And then I'm there, a living thing, like almost
looking back in time.
And I thought that traversed through the evolution of complexity. I just thought that was a very cool way to look at it.
It's amazing. Now, what about the other thing was the changes in climate that we talked about with Steve? What about the whole idea of the landscape being red? How did that grab you? That was one of the things Steve talked about. Is how do you identify Australia?
Yeah. It's red.
It's red,
red
and
AF.
It's flat. That was his two ideas. So, Did you see much redness out in the Flinders Ranges landscapes, or at least out in the plains nearby?
Yeah. So, well, even every time you go on Google Earth, and even when I was talking to Lachlan, he was like, I just want to know why it's so red. Why is this country so red? So, well, I mean, you see little green bushes and stuff, but stacks of red dirt.
A lot of red.
Everywhere. And turns
fine sediment. A lot of red, fine sediment soils.
Correct. And also flat, to your point, apparently that's not boring. I got to say, I came into the conversation with Steve going, oh, isn't it kind of boring that we're so flat? I take it back. The way that you two were talking about the beauty of plain rewired me. So,
well, we are biased against plains, like, because mountains stick up. There's an element of when you go to big mountains, your breath is taken away by their grandeur.
Yeah,
and they kind of impress on you. They look down on you. We look up to them like some like gods, like the gods live there, and they do live there in a sense, right? But plains are just the complete vacuity. They're the opposite. They are flat. They are unassuming. They invite you to. They don't corral you in any direction. They invite you to explore in every direction. There's no center. There's no, and so there is an enormity to a plain that is actually probably quite
unique.
Yeah, thank you. Yeah, unique.
It's unique.
Yeah.
And to your point about the forces that it takes and to build these tremendous mountains, then think about how tremendous the force is to
patient.
How patient.
How ongoing, how persistent the force to erode away a massive mountain range. Oh.
Correct.
The other thing about waking up in the desert, if you're ever lucky enough to camp in the desert, is, the desert is often quite still. We talk about stillness. I don't think I've ever had the stillness that I've experienced on waking up in my swag or in my tent on a desert, a cool desert morning where there is, there's only a couple of little bushes or maybe some grass around you. You're not talking like there's no creeks nearby. It's just the sands, and the stillness in the air. It's otherworldly.
I believe you. I also think that that's when the skies really show their force. I think that we feel quite detached from our skies, living in cities and light pollution. We don't see stars a lot. We don't even see the full majesty of a 360 sky. And in a desert, you're in the sky much more than you're on the ground.
Absolutely.
And I absolutely noticed how many satellites are up in the place lately. Like, when did all the satellites get up there? And it needs to
quite recently.
Yeah, it's ridiculous. It's like, oh my gosh, aren't we just changing the human documentation of our night sky just It's like our art's going to change overnight. Vincent van Gogh's Starry Sky. Anyway, that was a wild series of thoughts. I would like to go back to why Australia is red. Why do I see so much red out there?
I know. Well, this is the whole idea of that connects the idea of those gorges, and I think Steve talked about this. There was a time in the past, not that distant past, maybe 30 million years ago or so, 40 million years ago, when Australia was further south, but the climate was much hotter and the amount of rainfall was much greater. What happens when you have intense rainfall is you leach soils. So you leach away, groundwaters draw down and dissolve away lots of dissolvable elements like calcium and magnesium, and things that get left behind include iron. And so as the Australian plate has moved northwards, and Steve talked about it moving northwards at the speed that your fingernails grow, that inexorable gradual move has changed Australia's transition from a wetter environment to a drier environment as we've reached those sort of mid-latitudes where a lot of the world's deserts are concentrated. When you look at where the desert regions are, this is exactly those. This is a band, right? And that's all to do with circulations of air and the oceanic currents and that sort of stuff. But as we've kind of gotten rid of, or as the plants have died out because it's less wet. Yeah. All right. You're suddenly revealing those soils, and what's left is iron-rich soils, and that's why it's so red.
Oh, I love it. And I cannot wait. I will find someone that can talk to us about this, but I also feel like that these animals, those amazing, cute little wallabies that I love so much, and our kookaburras that I listen to in my morning shower, I can't help but feel that these unique, tremendously Australian animals are a function, surely in some sense, of how Australia has changed during its aridification through geologic time. Surely.
Surely.
Right.
Let's find out. Yeah. Let's find out.
I think it's nice. We came across a paper, as we go and do we have these conversations and go, oh, that's kind of cool. I'm going to read more on that. And some of these quotes, Anthony, we'll link it in the show notes, I think are quite beautiful. Do you mind if I just call them out?
Why not?
So we have, and I quote, humid landscapes with truly great lakes and rivers were transformed into arid lands with deeply weathered plateaus capped with laterite, desiccated river channels, deflated lake beds, and massive sandy and stony deserts.
That's so poetic. The way this is written for a scientific paper is beautiful. It really captures that transition. And, and if you look on the Google Earth imagery of Australia, you do see all these desiccated river channels. You see actually series of little lake beds that are all salt lakes now, salt pans now, but they all actually string along it's almost like the string of pearls you can see through the desert, right? They are those ancient channels. They are those ancient riverbeds from a time when Australia was much wetter and much more humid, right? and this is the whole idea of that. The current landscape, it kind of got these cryptic sort of indicators of the previous environments.
Completely.
Fantastic.
Completely.
So beautifully written. So beautifully written.
The lasting feeling I have from Andrew, and frankly, even Marco we haven't even spoken about Marco, but all of these conversations about what is encoded in Australian landscapes reminds me of mosaics, because it's what feels like a random artifacts, random features around you that just are what today looks like, just a little bit of a perspective shift. And all of a sudden, your history, far transcending your birth, far transcending your local city that you live in or outback that you live in, far transcending that is a mosaic of ancient worlds that are still here today.
Beautiful. And you sent me that link, and we'd love to share that. Yeah. One of those beautiful art installations where people have painstakingly taken, little dots or little kind of pieces of wood or something like that. And when you look at it from one direction, it seems like a random
mess.
Exactly. And then when you pan around and line up, just looking exactly the right direction, a beautiful picture emerges. And I think that's one of the joys of learning about the landscape, the environment that you live in. You can understand and you derive meaning and context from place rather than a simple textural or a kind of sensory experience. So this is the journey we're on.
Yeah, you derive connection. Oh, goodness, I needed this conversation. Thank you, Anthony.
Oh, it's lovely to talk. Thanks.
So to our listeners, you can find us on Instagram at the GeoCo. We sometimes chuck up some reels, some bits and bobs that would be cool to find us over there. We also have a recently published website, www.
I love the website. It's so well done.
www.awesome. thegeoco.com.au. Find us there. Get in touch with us. I think what would be really great is if send us questions. I've got so many questions.
I know we should do one where we can capture people's questions. I've had quite a few as well, and some great feedback. So thanks everyone's been in touch. We really appreciate the encouragement.
Keep it coming. I need compliments. Oh, just kidding. I hate attention. All right. Until next time, Anthony. Thanks so much.
Thank you, Holly.
Bye.